Hello, everybody. Welcome to a new episode of the Dissenter. I'm your host, Ricardo Lopes, and today I'm joined by Dr. Andrew Gallup. He's assistant professor of psychology and the director of the Adaptive Behavior and Cognition Lab at SUNY Poly. His research spans a variety of topics, including contagious behavior and comparative neuroanatomy, brain thermoregulation and vigilance, collective behavior and social cognition, aggression and sexual conflict, the evolution of cooperation, sports and athletic competition from an evolutionary perspective, biomarkers of Darwinian fitness, and the effects of neuromodulation on adaptive responses. So, Dr. Gallup, thank you a lot for taking the time to come on the show. It's a pleasure to have you on.
Oh, it's my pleasure to be here. Thank you, Ricardo.
Okay, great. So today we're going to focus our conversation mostly on the evolutionary psychology of aggressive behavior and also toward the end a little bit on yawning. That's a very interesting topic that I haven't covered on the show yet. So before we get there, let's start then with aggression. So from an evolutionary perspective, what are the kinds of behaviors that we classify as aggressive?
Yeah, so aggression is ubiquitous across the animal kingdom.
Mm-hmm.
So in non-human animals, aggression is easily spotted as some kind of physical, direct forms of aggression. So we might define aggression as a behavior that's intended to cause harm on another individual. And this is easily spotted with forms of physical aggression. It's very overt and easily identified. Within humans, as well as some non-human animals, we all can also see more non-physical and even indirect forms of aggression. So when it comes to our own species, we can be aggressive to other individuals without any physical violence whatsoever. We can utilize verbal aggression directly, or we can use more circuitous routes of aggression that we might call indirect forms of aggression, such as gossip, rumor spreading aimed at diminishing the reputation or assessment of rivals. And we can also utilize exclusion and isolation of individuals to serve it as an aggressive behavior. We see a lot of this in my research is primarily focused on aggression in adolescence, and we see the many forms of aggression take place among humans emerging in adolescence, and then that continues into later stages of the lifespan into adulthood as well.
Mm-hmm. So is it important for us to distinguish or to establish a difference between aggression and violence? Because I would guess that some of those behaviors that you described, particularly the ones that have more to do with verbal aggression, for example, would not be considered violent. Or am I thinking correctly or not?
No, I think you are. Yeah, no, I think we tend to consider violence as being falling within the realm solely of physical aggression. Yeah. Although in recent years there has been greater interest on the potential roles of non-physical aggression in producing harm, psychosocial harm, and we know that even non-physical forms of aggression can produce negative consequences to individuals. But yeah, I think we can make that separation with violence being a physical form of aggression.
Mm-hmm. So since we are talking about the evolutionary psychology of aggression, I guess that going back to the basics, are there any big sex differences when it comes to the forms of aggression that males and females resort to in our species and maybe in others as well?
Yes, there certainly are. So across the animal kingdom, we see that overt forms of direct physical aggression are more prominent among males of the species. And that's true for humans as well. Mm-hmm. So The sex differences can be explained by sexual selection and parental investment theory. Within sexually reproducing species, the sex that invests less into reproduction, on average, is usually larger, shows a larger sexual dimorphism in body size, and is also more aggressive and competes more strongly for mating opportunities. Mm-hmm. And we see that play out in some classic examples in non-human animals. But it also is the case for humans. There is a clear sexual dimorphism in body size in human males and females, and differences in upper body muscle mass, and the use of physical aggression differs. So males are more physically aggressive. They engage in more overt forms of direct physical competition, and this emerges fairly early on in the lifespan, and is something that continues through adolescence and into early stages of adulthood. However, I would like to speak to this in that saying that despite this difference in the use of aggression, because physical aggression is so easily documented, it's been long thought that males in general are just more aggressive, that men are just more aggressive than women, for example. When in fact, some research that I've done and others have done have suggested that there might not be a sex difference in the use of aggression. There's just this big sex difference in how women tend to aggress others. And this is where we see those indirect and verbal forms of aggression come into play. Mm-hmm. So women are much more likely to use these non-physical forms of aggression in encounters with their peers. So they're more likely to use verbal aggression to demean, diminish, embarrass others when in direct contact. So we would call that a direct form of aggression, although it's non-physical. And then women are much more likely to use indirect forms of aggression, such as spreading rumors, gossip, this kind of relational aggression that we see, and as well as aggression that might take place in terms of exclusion or isolation. And one reason for that is I think that can be readily interpreted from sexual selection and parental investment theories as well. Because women invest more into the reproductive act, the costs, the potential harm of physical aggression and violence are greater for women. And therefore, utilizing less physically aggressive tactics that still might be very effective in enhancing relative fitness provide greater advantages for women.
Mm-hmm. Would that also be because women, in terms of physical traits, for example, they have less muscle mass than men, and there are other physical traits that render them physically weaker than men, right?
Yes, the sexual dimorphism that I spoke to, it's certainly males on average are more likely to I guess, be successful in aggressive interactions. Mm-hmm. However, this brings up an interesting point with aggression, is that the vast majority of aggression that we witness is occurring within a single sex, so that men are aggressive to other men and that women are aggressive to other women. So the fact that women might not be as physically imposing as men are on average doesn't necessarily hinder their ability to be successful physically against other women. Yet we still see that women are more likely to use these indirect, non-physical forms of aggression.
Mm-hmm. You made a very important point there, because is it the case that these sex differences apply to both intrasexual and intersexual aggression? I mean, do the sex differences that you describe stand for both types of aggression or not?
Well, there are clear instances of aggression between men and women, and there are clear examples in which that type of aggression can be physical or non-physical. Yeah. But on average, even across these contexts, men are more likely to elicit physical forms of aggression that lead to violence than are women.
Yeah. So let's talk about specific phases of development that men and women go through, because I guess that there are particular periods in our life where we tend to be more aggressive than in others, on average, of course, and also perhaps display or make use of certain forms of aggression. So, when it comes to adolescents, I mean, is there something that is that distinguishes them in terms of the forms of aggressions they tend to resort to from other periods of people's lives?
Yes. So the adolescent period is obviously a rich developmental period, both physically and mentally. And we see that aggression begins to peak during early stages of adolescence. So adolescent interactions in bullying behavior and other forms of maybe traditional kind of day-to-day aggressive interactions show a clear spike during this adolescent period. And that is likely related to the onset of puberty, the development of secondary sexual characteristics, initiation in romantic interest, and dating involvement, as well as increased, cognitive, social cognitive abilities and interest in acquiring status within peer groups during adolescence. So I think the rise in adolescence that we see, or the rise in aggression rather that we see during adolescence, can be readily interpreted from an evolutionary perspective as individuals are kind of beginning to enter a phase in their life in which reproductive competition is becoming really important, and status attainment is also really important as it relates to that. And we see that adolescent aggression, again, is really consistently tied to reproductive motivations, as well as having tangible reproductive outcomes. So interest, or rather involvement in aggression during this critical period of development is associated with a kind of adaptive dating and romantic outcomes among adolescents here in the United States, as well as has been documented in other cultures. So men and women during adolescence, or boys and girls during adolescence, that utilize aggressive behavior toward their peers, toward their classmates, mostly intrasexual, I should say, boys being aggressive to boys and girls being aggressive to girls, tend to have adaptive outcomes in terms of dating. They're more likely to engage in romantic relationships with opposite sex peers. We see that women engage in relationships sooner, those that are aggressive, and they tend to have longer dating relationships. Boys that are aggressive to other boys tend to have more dating partners during this adolescent period. And aggression is a social behavior, right? So if you are being aggressive, that means that there is someone on the other end of that aggression. So the victims of aggression tend to have negative outcomes. So we've talked a little bit about the psychosocial outcomes and depression that can arise as a result of frequent aggression. But in addition, this translates into maladaptive outcomes in terms of their involvement in the dating or mating arena as well. They show diminished reproductive opportunities, or just maladaptive types of frequent dating with short duration that can have negative consequences, particularly for women. There's a clear kind of developmental trajectory that we see for aggression and its involvement during adolescence, and it's nicely coupled with beginning stages of involvement in romantic relationships. And aggression continues to stay relatively high in young adulthood, so that we see relatively high levels of aggression in the 20s, and then it begins to decline into the 30s and then thereafter. We also see differences in the uses of aggression developmentally. So physical and direct aggression in general, even non-physical direct aggression that might be verbal, is increased during these early stages of development, meaning adolescence and early adulthood, and then thereafter, those direct forms of aggression, likely due to the fact that they have significant reputational consequences. Right? There's social stigma to being aggressive. It's kind of universally viewed as something that's not acceptable. So we see that after a certain period, the benefits associated with being directly aggressive maybe are offset by these reputational social costs, and then we see more indirect forms of aggression come in place.
Mhm. Don't children, children that are going through infancy and childhood also exhibit aggressive behavior toward their peers, for example?
Yeah, so aggressive behaviors can emerge really early on in humans. And so even in infancy and toddler groups, there can be the development of social hierarchies and usually physical forms of aggression that are taking place at those stages. Yes.
Mhm. Yeah. Do you think that this knowledge could have some implications in terms of how we deal with bullying, for example, in schools? Because since these aggressive behaviors serve an evolutionary function, I think we could say that, then maybe it's really hard at least to try to suppress or eliminate at least some of these behaviors, right?
Yeah, I think that's a really important point, right? So the fact that aggression is just ubiquitous and consistently emerges around these times suggests that it has some kind of biological or evolutionary function. And this persists even though, right, students are taught from a very early age that aggression is very bad, it's not to be tolerated, and that we should be cooperative and pro-social. And despite that, despite the social stigma of aggression, it persists. So I think eliminating it completely is a very difficult task. However, I think the insights that we can gain from this evolutionary perspective can help inform bullying prevention strategies and ways to kind of curb or minimize aggression during this stage. So one possible way to do this would be to really incentivize and enhance the social consequences of being someone that is pro-social and non-aggressive, right? The aggression likely continues to persist within peer groups because of the benefits and the advantages that the aggressors obtain from perpetrating these acts. So if there's ways that we can kind of build into the social structure, which I don't, I don't admit to knowing these quite yet, but if there are ways that we can build into the social structure and the adolescent kind of network that, being the opposite of aggressive is going to come with advantages, and we can really kind of promote that. That might be one type of mechanism. We also know that among women, for example, or adolescent girls, that physical appearance can be a trigger for aggressive behavior. So individuals that are physically attractive and attract the attention of the opposite sex are often targets of aggression. And therefore, that knowledge could help maybe policies for adolescents wearing certain types of clothing or uniforms to make things more or less consistent across peers, to diminish these overt differences in physical attraction or display.
Mhm. Uh, could we say that aggression plays an important role in human development? I mean, is it the case that if we were to completely eliminate all forms of aggression, at least during infancy, childhood, adolescence, that, boys and girls would be missing something when they reached adulthood because they didn't go through these sort of ways of interacting with other people of their age? Do we know something about that?
I'm not sure that we do know a lot about that, but I think there's reason to suspect that engaging in these negative encounters with peers could help make individuals more resilient, okay, and stronger, being able to deal with various challenges later in life, right? We don't want to. I think there's good research to suggest that we don't want to, shelter children from negative experiences completely, right? So, although being a victim of aggression can have negative effects if it's prolonged and consistent, right? In like a bullying context, I think interacting with individuals that might be antisocial can help children develop cognitively and understand social cognition in ways to effectively deal with other people. It can help individuals kind of navigate the social world and learn about ways in which they can acquire resources, develop allies, avoid individuals that might be a threat. So I think, these dynamics in childhood and adolescence ultimately help prepare individuals for adulthood in many respects. But I think it's a tough argument to make, right, that we should let kids just be as aggressive as possible because it might have some of these advantages. I still think we want to be on the side of trying to diminish it due to the negative effects that it can produce. But it's never going to be completely eradicated.
Yeah. So at a certain point there, you mentioned the fact that when people reach adulthood, usually, or I mean, a little bit after young adulthood, let's say, their levels of aggression drop. Does that happen regardless of the circumstances they're in? I mean, I guess I would focus on their relationship status because I've read some studies. I don't know if this is still true, but they said, for example, that when men marry and have children, their levels of testosterone drop, and that would be one factor that plays a role in their aggression also dropping. But that would mean that they would have to be in a relationship that they see is long term or will last a long time, and also have children. So if, for example, boys or young men don't go through that, is it the case that their levels of aggression also drop? Because I would guess that from an evolutionary perspective, it would be, I don't know, perhaps important for them to be a little bit more aggressive until they get a partner and settle and things like that.
Yes. So aggression is very context specific, and decline that we see is kind of an average population decline that occurs in the late 20s and into the 30s. But I would agree with you that individuals, and particularly males, that are single, that have not married, are going to be more likely to continue patterns. Or their aggressive behavior is at a group level is going to be higher on average than males that are married and have developed families and have children. And this is in part due to the engagement and competition that those two groups of men might be in on a day-to-day basis. Males that are single might be more likely to engage and compete directly with other men, while males that are partnered might no longer kind of pursue those types of activities. And then, as you indicated, there can be major changes through endocrine changes in testosterone following the birth of a child that may further modify behavior. We know that there's a positive correlation between testosterone and aggression. It's difficult to know the causal relationships there and how context plays a role, but yeah, that should reduce aggressive behaviors in general. Aggression is very context specific, and the type of context may also modify the type of aggression that's used, right? Because of the social stigma of aggression, in certain situations, it's more adaptive to potentially use indirect forms of aggression to minimize any type of reputational effects from on the perpetrator. But in other scenarios, direct forms of aggression might be better.
Mm-hmm.
So absolutely, it's a good point to bring up that context is very critical to understanding aggression.
Mm-hmm. And it's critical also to understanding it because, I mean, I think I've read this in Sapolsky's Behave, the book. At a certain point, he talks there about the role that testosterone plays in our behavior, and he mentions the fact that it seems that testosterone is not does not directly cause aggressive behavior or violence, but it depends a little bit on the context. I mean, if what gives you or what increases your status, for example, is for you to be, let's say, an intellectual or someone that is able to distinguish himself in terms of acquiring resources of other kind that don't imply aggressive behavior, then I mean those people, men particularly, that are more successful independently of the way they reach that position, also tend to have higher levels of testosterone, and that in those cases don't really correlate with higher levels of aggression. Perhaps competition in other ways, I guess.
That's right. Absolutely. Yep.
Mm-hmm. Yeah. So in your work, when it comes to aggression, you talk. There's a particular study that I read where you talk about the relationship between hand grip strength and dominant behavior. So could you tell us about that?
Yes. So some lines of research I've explored have focused on hand grip strength in particular, and its relation to aggression, social dominance, and my interest in hand grip strength came from the fact that hand grip strength is a really good indicator of overall physical strength. So as it turns out, if you're going to just obtain a couple measurements of upper body strength, hand grip strength is the one that's most useful. It's positively correlated with all sorts of other indicators of physical strength in the individual, and it's really easily obtainable through the use of a hand dynamometer, which are readily available. They're often used in medical settings, but now more commonly now in social science and basic research settings because of the value that this measure has shown in behavioral sciences. So hand grip strength as a measure of strength is useful, right, when we assess overt forms of aggression and physical aggression. We might think that individuals that are more formidable and have greater strength might be more likely to display that aggressively and use that to their advantage in competitive contexts with peers. Another really interesting thing about hand grip strength is that, as I mentioned, its reference to medicine, it's a really good indicator of overall health and vitality among individuals. So for both men and women, measures of grip strength are positively correlated with health, longevity, recovery, post-operative recovery from surgery. They're associated with other physiological indicators of health like bone mineral density. So some basic measure of physical strength is really a good cue to health status, okay? So that's really interesting. And from an evolutionary perspective, we know that hand strength, grip strength, has kind of an interesting heritage, right? So in an arboreal environment, grip strength is essential for daily life, right? Your ability to hold yourself suspended is living in the trees is absolutely essential. And we see remnants of this in our own species. So babies that are born, even moments after birth, show this classic grip reflex, where if you stimulate their palm or their fingers, they'll clasp it down. And there's nice images of this. The grip strength of newborn babies is so strong that they can hold themselves suspended in air, even just minutes after birth, which suggests that this is kind of an innate reflex from our evolutionary history in which babies had to cling to their mothers in order to survive. So from an evolutionary perspective, grip strength is very interesting. And then when we apply it to aggression, right? So there's a clear sexual dimorphism in this measurement. It's robust, in fact. So while grip strength is positively correlated to health outcomes, both for men and women, men consistently outperform women on measures of physical strength and grip strength in particular. And this occurs throughout the lifespan, emerging in later childhood and early adolescence. So among very young children, no differences in grip strength are present. And then at the emergence of puberty, we see these differences really become quite dramatic, and they persist throughout the lifespan. So some of my research has examined how this measure of physical strength might be related to aggression and social dominance. And in fact, that we show that it is. But interestingly enough, it is only the case for men. So grip strength is positively correlated with uses of aggression and dominance over peer groups for adolescent boys, but not girls. And then among young adult populations, we find the same thing, that grip strength is positively correlated with dominance and aggression for young men. But again, doesn't really contribute to variance in those measurements for women. And then further research suggests that aggression, or rather that hand grip strength is positively correlated with other aspects of body morphology in men, such as broad shoulders, physical appearance like facial attractiveness is positively correlated with hand grip strength. Other indicators of formidability. So aggression, or hand grip strength rather, is also positively correlated with reproductive success and measures of sexual behavior and even reproductive fitness in some populations. So there's a good deal of evidence to suggest that this measurement of strength is not only really useful in the behavioral sciences, but through this research, it's kind of suggested that physical strength, in particular hand grip strength, has been under directional selection during human evolutionary history, and maybe continued to be elaborated in contemporary populations. So because physical strength plays a role in male-male competition, it's likely been selected for through intrasexual sexual selection. And because indicators of grip strength are positively correlated with physical attractiveness and sexual behavior, it may also have been selected through forms of intersexual selection. And from an evolutionary perspective, research on hand grip strength suggests that in hunter-gatherer populations, for example, among the Hadza in Tanzania, hand grip strength is positively correlated with hunting success. And as a result, we see that hand grip strength corresponds with reproductive fitness and success among the men in those populations. So it's a really interesting measurement, and it's been continued to be used in the evolutionary behavioral sciences, and consistently shows positive correlations with social and sexual competition among men, and really no relationship with those outcomes among women. So it's a really sexually dimorphic trait, and I think there's a lot of research still yet to be done examining the full range of variables that this measurement predicts.
Yeah, this is all very interesting. And at a certain point, when you mentioned the correlation between hand grip strength and certain health indicators, could it be that what's behind that is the fact that people that are the most physically active also tend to have bigger hand grip strength and then that physical activity also tends to correlate with certain health indicators.
Yeah, so there is evidence that there can be some, through the use of exercise and interventions, there can be some influence on one's grip strength. So if people exercise their forearms and upper body, that you can obtain some incremental increases in grip strength. But this measurement is fairly constrained. So it's modified by environmental variables in adulthood only modestly, and it has a really significant genetic component. So the heritability of hand grip strength is really, really high in studies of twin studies, which suggests that this is a trait that has a strong biological component. So I don't think that the range of health outcomes it predicts in adulthood can be really vastly explained by exercise and environment, although those are going to play a role.
Mm-hmm. So there's sort of a genetic predisposition maybe to have both higher hand grip strength and maybe other positive health indicators.
Yeah, I think these are going to be related because testosterone is positively correlated with hand grip strength and lean muscle mass in general, which is associated with health. So I think that the relationship between these variables, grip strength and health, it has a clear connection evolutionarily for why strength was important under ancestral conditions. Yet we can see that strength is still important to kind of basic health and physiology in contemporary populations as well as it relates to other variables that would be related to strength and underlying health. Mm-hmm. It's interesting for women, the heritability estimates for hand grip strength are half that for men. So there's a significantly stronger genetic component for upper body strength measurements in men than there are women. And additionally, the age-related declines that we see in strength. So strength measurements in both men and women peak in the late 20s and middle 30s. Mm-hmm. And then they begin to decline thereafter into older age. The age-related declines for men are found earlier compared to women. So although there's a significant difference in that men are physically stronger robustly at their peak, there's a more rapid decline that occurs thereafter that coincides with some of these endocrine changes and decreases in testosterone that we see, that may also be coupled with contextual differences in marriage and having children, some things we've talked about earlier.
Mm-hmm. Yeah, that's very interesting. So let's talk now about yawning. So what is the evolutionary function that yawning serves, if there's any, of course?
Yeah, so yawning is ubiquitous, or yawning are very similar motor action patterns where there's this gaping of the jaw, extended gaping of the jaw, that in terrestrial vertebrates appears to be accompanied by this respiratory component. It's been documented across vertebrate classes, which suggests that it emerged a very long time ago during vertebrate evolution, perhaps emerging with the first jawed fishes. Now, since its origin, we see that it has been highly conserved across lineages, and that suggests that it likely serves some underlying function biologically. Right, and some of my research has examined what might be the physiological function to yawning. Now, yawning takes a number of different forms. Okay, its most primitive and ubiquitous form are these non-social forms of yawning that we would refer to as spontaneous yawns. yawns that can emerge physiologically in the absence of any social inputs, right? And these types of spontaneous yawns are likely the origin of this behavior, and then any socially elicited forms of yawning are kind of a derived component that has evolved more recently within social species. Now, what the function of yawning it's kind of still being examined, right? Despite the fact that humans yawn every single day and begin yawning within the womb. So it's very, very common behavior. Researchers don't know that much about it. So I was very interested and took on ambitious projects to try and examine the physiological function of yawning. And through this work, basically we've been able to kind of pinpoint the major physiological consequences of this motor action pattern. So yawns can be described as this extended gaping of the jaw or stretching of the mandible that occurs with peak muscle contraction with a temporary pause, so it's delayed and extended, and it includes a deep inhalation of air, and then there's a rapid closure of the jaw and an expiration of air, right? And the coupled components there, that really extended muscular contraction and stretching of the jaw with that deep inhalation of air, serves to increase blood flow to the skull. So we see dramatic increases in arterial blood supply, and that action also forces venous return away from the skull. So we see that one primary function, which is localized to this motor action pattern, is intracranial circulation. Okay, and from enhanced intracranial circulation, that's going to produce a number of physiological effects or consequences. And my research has examined the potential role of yawning and brain cooling in providing thermoregulatory effects neurologically. Brain temperature is determined by three variables. It's determined by the rate of blood traveling to the brain, the temperature of the blood traveling to the brain, and metabolic heat production that's going on within the brain. And the motor action pattern of yawning alters those first two variables. It increases the blood flow to the brain and modifies the temperature of the blood within the brain. And it does so in part by forcing hyperthermic blood away from the brain through venous return, while simultaneously introducing cooler blood from the lungs and extremities. Now, the respiratory component of yawning that includes this deep inhalation of ambient air, we have proposed that serves a cooling function in promoting countercurrent heat exchange. So the contact of that inhaled air with nasal and oral surfaces comes into close contact with venous blood supply that could subsequently cool arterial blood traveling to the brain through convection. And we've examined the connection between yawning and brain cooling in particular through a number of studies comparatively in non-human animals, but also within humans in the laboratory. And all of our research suggests that indeed there are thermoregulatory consequences to yawning, and that as a result of the changes in blood flow that we've discussed, and that you can modify the expression of yawning, its frequency, through thermoregulatory manipulations, so that cooling of the brain or the carotid blood supply, which we've shown cools the brain through thermal imaging, reduces yawn frequency. And alternatively, warming of the blood traveling to the brain, or by applying warm compresses to the skull, those increase yawn frequency. And similarly, we've shown that ambient temperature manipulations modify the frequency of yawning. So just as would be expected, if yawning is a mechanism for cooling, if you rise ambient temperature and you warm the environment, you should increase yawn frequency. And we've shown that reliably both in humans and non-human animals. And similarly, if you drop temperatures down below a thermal neutral zone, cooling mechanisms should be shut off, and warming mechanisms would be triggered. And we've shown that in colder climates and cold temperatures, yawning is diminished just as we would expect. And then the last line of research to support this connection between yawning and brain cooling in particular is the fact that we've monitored brain temperature in laboratory animals, and we've been able to demonstrate clear associations between yawning and intermittent changes in brain temperature. So that preceding yawning events, we see stark rises in brain temperature in rats, for example, that have thermocouple probes in their brain. And then once they yawn, their yawns appear to be triggered by these rises in temperature. And that once they yawn, we see these corresponding decreases in temperature thereafter. So collectively, these findings really kind of suggest that there's a clear association between yawning and thermoregulation, particularly within birds and mammals. Now, as it neurologically, yawning appears to be under the control of the hypothalamus, and the motor action pattern of yawning itself is kind of a brainstem process. However, because of the purported function of yawning in promoting intracranial circulation and cooling to the brain at large, we have proposed that animals with larger brains should have longer yawns and yawns that are more powerful in order to produce the same physiologic effects. So as brain size increases, heat dissipation, the needs for heat dissipation, effective heat dissipation, increase as well. So animals should be expected to display these longer yawns as a result. And we've done comparative studies now, a number of comparative studies across vertebrate species, mammals in general, as well as smaller taxonomic scales of vertebrates, such as a single family of mammals, and then most recently within a single species of domesticated dogs, which have a wide variation in brain morphology within a single species due to artificial selection. And we've shown in all cases that animals with larger brains, species or breeds, when it comes to dogs, have consistently longer yawns on average, even when taking into account body size differences. And this research further kind of supports the idea that yawning serves an important neurological function, which is consistent with the research on yawning and brain cooling.
Mm-hmm. So this brain cooling that yawning supposedly promotes, is it associated with certain specific physiologic functions in the brain? I mean, do you know anything about that?
Yeah, so we know that certain contexts increase or modify brain temperature, right? So stress and anxiety are known to increase brain and body temperature, and they're also commonly documented to elicit high-frequency yawning. The cooling that results from yawning is widespread. So we have demonstrated this not only within particular anatomical regions through the couple brain temperature probes, but we've also been able to monitor the cooling effects at the surface of the skull using thermal imaging cameras. So through the use of thermal imaging, you can monitor changes in the surface temperature in laboratory animals as well as humans. And we've shown that the cooling that occurs following yawning is something that can be documented at the level of the eyes and the ears and areas that have a high sensitivity to temperature because of circulatory tissues. So it appears that the cooling is really widespread as a result.
Yeah. So one last question: is yawning really socially contagious? Because I mean, we have this idea that when one person yawns, it increases the probability that someone next to her will imitate that behavior. Is that true or not?
It is within our species, and then so far, about a half a dozen other species have been documented to show what's called contagious yawning. These socially triggered yawns, and in our species, they can be elicited, and it's been demonstrated in the lab that they can be elicited through visual stimuli, seeing someone else yawn, auditory stimuli, a combination of those two, but also just reading about yawning or thinking about yawning can produce this response. So this is what I was talking about before with this more recently derived feature of this response. And so far, contagious yawning has been documented clearly in humans. It's often studied in humans, and some other species like chimpanzees. Domesticated dogs have been shown to yawn contagiously in response to human yawns. So there's interspecies contagion that may be a result of domestication and selecting for psychological traits in dogs where they cue into human social cues. And then recently, even a bird species, parakeets, have been shown to yawn contagiously. So I think as time goes on, we'll find that more and more species might show this trait, but it's clearly limited to highly social species, and may have taken on some additional derived function. Okay, so if spontaneous yawning serves to increase circulation to the skull, that might have these thermoregulatory outcomes, right, and cooling the brain, that's going to have consequences in promoting arousal, perhaps increasing alertness and mental efficiency, right? So the fact that yawns occur during behavioral transitions and states suggests that it plays a role in state change, and under certain contexts in particular might serve to promote arousal and alertness. Now, if that behavior spreads through the group via contagion, it could serve to promote, kind of overall collective vigilance and improve awareness of the collective as a result. So we're beginning to examine, some of these questions in the laboratory, but right now there's no clear, definitive understanding of why contagious yawning evolved or what function it serves. It also could simply be a byproduct of social cognitive mechanisms in highly social species, right? It's elicited kind of automatically and reflexively, and it might not necessarily serve a function either. So there's research going on right now to examine some of these things.
Yeah. Okay, so Dr. Gallup, let's end the interview here. Before we go, where can people find you on the internet?
So I have a personal website at the State University of New York Polytechnic Institute, and from there they can access some information about my research interests, and also I have a Google Scholar page and Twitter that I post to and can be used as a resource for contacting me.
Yeah. Okay, so I'll be leaving links to all of that in the description box of the interview. And thank you again for taking the time to come on the show. It was a real pleasure to have you on.
No, it's all mine. Thank you very much for the invitation.
Hello, everybody. Thank you for watching this interview until the end. I've started this channel back in February 2018 and have been putting out regular interviews with academics and intellectuals from a variety of fields. So, to keep the channel sustainable, I would like to ask you to consider making a pledge on Patreon. I have the link in the description box, or on PayPal. You can also find the links there. And otherwise, and if you like what I'm doing, please share it, leave a like, and hit the subscription button. I would also like to give a huge thank you to my main patrons and supporters on PayPal: Karen Litzke and Blanchett Peroga Larson, Laguerrero, Francis Ford, Hans Fredrik Sunda, Ricardo Vladimiro, Craig Healy, Adam Kessel, Olaf Alex, Jonathan Wiesel, David Diaz, Anian Kata, Jacob Klinkby, Matthew Whittingbird, Arnold Wolf, Tim Hollesy, Henry Kalenius, John Connors, Paulina Barron, Philip Forrest Connolly, Jerry Mueller, Herbert Gintis, Rutger Voss, Bo Weingart, Rebecca Newberger Goldstein, Dan Demetriou, Robert Rui Inácio, Arthur Coe, Zoop, Marco Neves, Max Bailey, Colin Holbrook, Susan Pinker, Thomas Trumbull, Bernardo Seixas, Pablo Santurbano, Simon Columbus, Jorge Spinha, Phil Kavanagh, Corey Clark, Mark Blythe, Roberto Inguanzo, Michael Stormer, Eric Neumann, Samuel Andreev, Tiago Nunes, Bernard Hughney, Alexander Dunbauer, Omari Hickson, Felicia Stevens, Fergal Cusson, Evan Bodrenko, Al Herzog, Nuno Machado, Don Ross, João Alves da Silva, Jonathan Librant, Oslam Bullitt, Nathan Nguyen, Staten T, Samuel Correa, Eric Hines, Mark Smith, J.W., João Eira, Tom Hummel, David Sloan Wilson, Yacila Deza Araújo, Ethan Solon, Romain Roch, Dmitry Grigoriev, and Diego Londoño Correa. My producers, Isar Webe, Jim Frank, Lucas Stafiniak, Ian Gilligan, Sergio Quadriano, Luís Caetano, Matthew Lavender, Tom Van Egdam, Curtis Dixon, João Linhares, Benedict Mueller, Vega Guidi, Sardus France, and Niruban Balachandran. And my executive producers, Michal Rojewski, Rosie, and James Pratt. Thank you for all.